I think next up we do have Matteo Rosi and Paolo Spagli, who will be talking to us about automating serverless security testing. So obviously serverless is something that is increasing a lot in adoption. There's a lot of that's happening. So this is quite a interesting topic and quite current as well. So we are definitely looking forward to the topic as well. Welcome, Matteo.
Thank you very much. Hello, everyone. I'm quite excited after Tanya. It's an honor for me.
Yeah, I agree with you. That's our house is in front of you, and now you're gonna all jam pack for the talk.
No, I have all the slides, but Paolo talk in the second part of the speech, so I can start now, and we
Sure.
Oh, okay.
Absolutely. So you're gonna start now, and then Paolo will join in, right?
Oh, okay. But he should already in the backstage, but okay.
Sure. So we'll just pull your slides in,
yeah,
and get started with the talk.
Okay.
Amazing.
Yep.
Okay.
Perfect. You're good to go, Matteo. Your stage is all yours.
Thank you very much. So, good morning, everyone. I'm Matteo Rosi. I'm a security researcher in Contrast, and in my past, I'm working as in defensive and offensive field of security, and also I was a software developer, so I merge all the souls for this talk. And there is also Paolo, my colleagues.
Hi everyone. Sorry for the inconvenience. Obviously, Chrome close in the exact minute the stream starts. So hi everyone. I'm Paolo Spagli. I'm senior security researcher at Contrast Security. In the past, I worked at Baker Hughes in cloud engineering and architecture for almost 5 years.
Okay, so we are starting to talking about cloud native application and serverless application. And for us, this kind of application is not only the development pattern. Yes, of course, we don't have the difference from a monolithic application is quite clear. In the cloud native application, we have many resources, many microservices that are configured to talking each other with the events. In a monolithic application, we have a great code base that handle all the flow, all the data flow. And to support, to develop, to create this kind of application, we need to change all the phases of the development. We have to change the cycle. We cannot proceed with a waterfall approach when we try to develop this kind of application. We need to go with the agile method, but not only agile, hyper agile. We need to approach with the DevOps process, DevSecOps process, of course, because we need to deploy many times in production for day. So we need to handle the security. We need to handle this development in different way. And so we have many steps to do to deploy in production in this kind of application. And so it's mandatory need to automate every process, every step to go to permit the application to go in production. And also the developers. The developers has more responsibility for this kind of application because every developers usually needed to deploy in production more times per day. So of course, more power bring more responsibility. I don't remember who says that, but and so we needed to change completely this kind of approach. We bring an example of a cloud native application. This is this graph represents a small application from our customer. So you can see it's a huge number. There is a huge number of components connected each other and communicate each other with events. So testing manually this kind of application is really difficult. It's really difficult to testing manually, to deploy with a single process, no? Like I said before, with a single deployment process, like a monolithic application. What means I have to change all the components together? No, I need to have a DevOps approach, change a single component while the other components continue to work with it. So a green-blue, for example, a green-blue method to deploy in production. This is an AWS application, so you can see different components with different color. The purple one is an API gateway, so each API gateway is exposed or internally or externally, I don't know, some endpoints. And the orange components are the Lambda. Why are we talking about orange components? Because the Lambda is the component that contains the code developed by the developers, by the customer. So we're talking about events. The architecture of this kind of application is a event-driven architecture. So every component talking each other using events. The events trigger the execution of the components. In that case, we have many triggers many components that generate events that trigger a Lambda function. The Lambda function contains your code and how it's work. The cloud service provider, when an event triggers the Lambda, create a container, boot up a container with your code, run the code, and after the execution, terminates the container, usually. And this is another thing, because the cloud service provider, for performance for performance, usually cannot terminate the container, but reuse it to handle another events. And this is can bring some security events we're talking about later. So in that case, your code inside the Lambda, and of course with your code, usually there is also your mistake and your bugs. Another overview about security aspects in the Lambda. The Lambda usually is run in a container in a read-only environment, except the TMP directory is the only directory where you can write something. It's not wired to the internet, but can reach the internet. This means you can talk with the container, with the API gateway, with the other components that expose the service on internet. And you cannot communicate directly with the container, but the container can reach the internet. And with the demo, after the slides, I can show you how exploit a vulnerability inside a Lambda, and the Lambda communicate to the internet some sensitive data. So I can implement an exfiltration from that container. The data usually is temporary because the container is ephemeral, but of course, for performance issues, sometimes a container can be reused. And also, the code is inside the environment. It's inside the container. So if you have a local file inclusion vulnerability, LFI, you can lose the privacy of your code. An attacker can exfiltrate your code, and also can exfiltrate the environment variables. And in this kind of in the container, there is all the sensitive data, the AWS key, secret key, inside the container, inside the environment variables. This is some aspects we need to understand to create a secure application. So, what could go wrong in that case? This is a simple, the simpler application. We expose this application expose an API REST to the internet. We have the client that communicate with the API gateway. The API gateway generates events that trigger the Lambda. The Lambda run with the context, with the role. The role is a permission used by the Lambda inside the cloud service provider. And so the Lambda can access or read or write, I don't know, with a DynamoDB instance. So could go wrong with this kind of application. I can test it using OWASP ZAP application. I can generate HTTP call to understand if this application is vulnerable or not. Yes, it's true, but this is a kind of cloud native application. What's happened if the events is not generated by the API gateway, but by, I don't know, an Alexa skill, for example? I don't think the OWASP ZAP working with audio trace, audio with multimedia, and able to generate malicious payload in audio. And this is different. It's completely different, and we cannot test with the common security tools. And I will share with you a YouTube link where our head of research, Tal Melamed, tried to exploit a SQL injection vulnerability inside an application with this architecture. I share after this speech. So a quick demo. I want to show you how we can exploit a famous Spring vulnerability. It's not Spring for Shell, but it's the other one, the Spring expression language vulnerability. This generate remote code execution, this bug. And so I will show you how we can exploit this to exfiltrate some sensitive data from a container. Of course, not demo effect, it's not the demo effect. So you can see I insert a payload in a header, HTTP header, the root expression header from Spring. I run I make the call with the Postman in that case. And I try to exfiltrate this data using a server in my control. And can you see in the bottom part of the screen, the secret key exfiltrated from the container. What happens? There is a bug, a vulnerability inside the Spring framework. If you want to use Spring framework in the Lambda, you can use it. And when you trigger the Lambda, the cloud service provider going to call a function from the Spring framework. That function has a bug. This bug can be exploited in this way with a simple payload inserting an HTTP header, and something can happen. In that case, I exfiltrate the secret, and so using that secret, I can run some code in the same context of that Lambda, with the same permission of that Lambda. So it's quite clear that one of the things we're going to lose when we approach with the cloud native application, we lost the perimeter. In the monolithic application, we have a load balancer or a reverse proxy in front of the application. Sorry, in front of the application, and the load balancer route every call to the components that have to handle that flow. And after the load balancer, every flow are handled by the monolithic application. In the cloud native application, the serverless application is not true. It's not true anymore because, okay, I have the API gateway that route a single call, a single kind of call, but I can have more API gateway that trigger more different kind of Lambda. But also, if I have to upload a file, I have a S3 bucket that take the file, trigger an event, and call another function. So we're going to lose this perimeter. And so we needed to change the way how we secure the application. We need to go through a zero trust approach, a least privilege approach, to secure the perimeter of each Lambda. And of course, we have to go through the self-protecting code. we need to harden each component of this kind of application. Another example, in this case, I talk about the least privilege approach. No, we have a very simple Lambda, 20 line of code. This is a Lambda that that place an order in a commerce, in a cloud native commerce. And you can see in this line, we have a DynamoDB instance, a table, orders table. And we can see the code going to put an item inside that table, no? Only one order. So the context, the rule used by this function is this is the rule is the permission, no? How the Lambda can do. In that case, we have an action, so the permission, and the resources over used by the Lambda. No? In that case, this Lambda can do any action in DynamoDB in any table of this instance of DynamoDB. It's quite too open permission. So we see we use only path item, so we can harden this rule and put only the path item action to avoid this Lambda make some other action. And of course, the resource only the orders database or orders table. All the access to the other tables is not unused in this Lambda. So why give the permission? No. So it's quite easy to do this manually with only one function of 200 line of code, 20 line of code. But what's happened if you have 100 of Lambda code, more long, more 100 line of code of 100 Lambda? It's quite difficult to do this manually. And so we need to automate this process using a DevSecOps approach. So we're talking about event-driven application, no? So we're talking about change approach, change how we can see the security in cloud native application, and also OWASP. I think everyone know the top 10 OWASP. Also, OWASP change the top 10, adapt it to the cloud native application. In that case, I show you the top 10 for a serverless application. And of course, the first one is event injection. We're talking about event-driven application, no? So it's natural, it's obvious. So, Paolo, up to you. Thank you very much, guys. Thank you very much to join us.
So let's show my screen. So, how we can test a serverless application? Let's see.
Paolo, we can. Okay, now we can see.
Okay, thank you.
Sorry.
So, how we can test a serverless application? I have taken this example from AWS Case Studies website. It's from the iRobot Roomba system. This is just one flow of the entire system, but it's a good, simple example to see for the talk. So as you can see, a device in iRobot Roomba try to register himself on the system. So you have an API exposed using API gateway. API gateway trigger Lambda that talk with AWS IoT and send a message into the queue. The message in the queue trigger another Lambda that complete the registration process, adding the right information in the registry, setting the policies and the IoT rules. A simple application, and let's see what we can do with traditional application security tools on this application, how we can test it. Let's start with the easy one, SCA and image scanning. So you can run Snyk or Claire or any other tool. There are many also open source and provided also by cloud service provider. With this type of tools, you fix the problems that you import using the third-party libraries, so which is a good thing, as we have seen recently with the most important vulnerabilities. But this scan covers a small part of your application. It doesn't cover your code, the infrastructure that support your code, and the configuration, as Matteo was talking a few minutes ago, of your lambdas and your cloud services. The next, infrastructure as code. Fantastic thing. So we can shift left, we can do DevOps, we can run a security scan of your Terraform template, or if you're using Pulumi, you can scan your code. But again, we have zero code coverage, limited visibility, and also we don't have prioritization, because these type of tools, for example, give you that as a result that you have 100 of public buckets without so much context. So you have to go and check each one of them. But if you are, for example, exposing a website, it's lazy to have public buckets, and but maybe in some cases no. So you have to check one by one, and is adding effort and noise to your work. IAST. So IAST is the modern AppSec tool. I think is the most accurate and reliable tool that we have today. Enables DevSecOps. But again, in this environment, we don't have servers to instrument, so it's difficult to put in place IAST in a serverless environment. Dust. Dust is another great tool, but it needs endpoints to be tested. It needs the response to be checked, and in serverless environment is not always the case. Looking at this, at our example, you may be able to test this API exposed by the gateway, and maybe the code of this Lambda if the Lambda is synchronous. But in many cases, we have an asynchronous response, like we got your request, you are all set. That's it. So you don't have something to check in the response. So again, maybe you are able to test this part of your application, but for sure you are not able to test this part that is triggered by the queue message. So it's not possible to reach and to cover this piece of code using Dust. So you may have nothing to test with Dust. SAST is another great tool that can give you great feedback on the code of all your Lambdas. You can run SAST on all your Lambdas, even if maybe you may have some issues on scaling if you have a lot of Lambdas. But the main issue with SAST is the fact that you don't have context. You lose the context because serverless is not just code, it's code and infrastructure. And SAST tools are not configured to look at the infrastructure and the configuration. So you may lose context, and also you may have some difficulties due to the flow, because the flow is not linear. So you may have in the middle of your Lambda a call to another cloud native service, and so the tool can provide you strange result or increase the number of false positives. So as you can see, there are many tools. Each one of them is giving you something, so it's good to run, but it's also a lot of effort put them in place in a serverless environment, and maybe it's not worth it because the results are not effective. In addition to this, there is another key point in cloud native and serverless environment, that is scaling. So it may be enough, or if you have few lambdas, but what if you start having thousands, or if not million, as we have seen in some of our customers, lambdas? So in that case, you have a lot of services. It's difficult to understand what is connected to what. Also, you have frequent deployments, because DevOps and cloud are environments that increase the number of deployments. You obviously, if you have many lambdas, you have many developers, and the number of AppSec people remain normally the same. So it's, and as Matteo was showing before, security is not even the same in a serverless environment. So basically, you may lose the focus on what's important, because as you know, in security, it's not possible to look at everything. So you have to prioritize based on the risk of vulnerabilities. And so with all this noise and all these things to look at, you can lose the focus on what's important. So we suggest to have a different approach with a different mindset, that is installing an agent in your cloud environment, using a seamless and fully automated onboarding that is possible in the cloud with few clicks. And then this agent can run a full discovery of your cloud environment, looking at resources, the relation between the resources, the interfaces, policies, and also all the services that are used within the environment. When the discovery is done, the agent can run an analysis that look at your code first and foremost, then at the weaknesses, at the attack surface, the flaws that you have in your system, so that then using this information, the agent can generate and execute dedicated attacks on resources and flows. For example, if you have a Lambda triggered by an S3 bucket, the system can generate dedicated attacks to see if the Lambda is vulnerable to local file inclusion or other type of attacks. So when continuing in the flow, as we have an agent installed in the environment, we are internally, so we can see if the simulation have an effect, so if there is a real exploit or not. So we are not like dust that we are outside, and we test the application as a black box. In this case, we are in, and we can check we can check the logs, we can check the database, we can use many services and tools to check if we have a real exploit, and show and send it back to you. In addition to reporting and integration, because maybe if there is a vulnerability or some findings, you can send a message into a Slack channel. The nice thing is that we can also continuously monitor the environment for changes and drift. So if a developer add a new API or change the code of the Lambda, we can change what has been changed in order to have a fast feedback loop, and give immediate feedback without doing anything, without any action from the developer. And so you can keep the environment under control. So with this approach, also if someone creates something new, we can run again the complete analysis, if it's a new system or a new Lambda or a new service, and do the loop again. So we can make continuously monitoring and continuous scanning of your cloud environment without intervention or something similar. So let's see an example, very simple example. So if Mario, the developer, had a new API that trigger a Lambda, we can identify the flow of this API. So we can see that it triggered the Lambda, that then upload a file into a bucket, that then notify a Lambda, and the Lambda send an email to the customer. So we can scan this flow for vulnerabilities. We can scan each component in isolation by themselves, and we may be able to identify a vulnerability in this function. So we can get the result, maybe we are able to get the access key, and so we can identify the impact of that vulnerability. So you can see that the storage, the S3 bucket, the function, the email for the customer, and maybe more important, the DynamoDB tables can be accessed by a potential attacker if is able to exploit that vulnerability. So this is it. Just few words. So at Contrast, we recently released a CLI we called CodeSec by Contrast. Is for serverless, so you can use it for free, and you can start playing with it. You can get result in less than 1 minute, and you can see if result for your lambdas. You can have a least privilege approach, as Matteo was talking before. You can see if there are vulnerabilities and so on. So feel free. You're more than welcome to go to the website and start playing with it. Your feedback is more than welcome. At Contrast, we also contributed to a couple of OWASP projects, the Serverless Top 10, as Matteo was mentioning before, and also the classical vulnerable application developed using serverless technology for testing purposes. Thank you very much for joining us. Feel free to reach out with your questions. We will be more than happy to.
Yeah, sure.
Thank you so much, Matteo and Paolo. It was amazing. I was just going through every part of it, and you really stitched it very well. Especially serverless is something which is right now needed the most.
Yeah,
So
thank you very much. Yeah.
It was totally amazing, and a lot of people are waiting for you on the channel that we have on. So please do check that out. And yes, everyone, do join us on Discord as well. Now, before we head out, I do see one question for you. Actually, they've actually said that it's good, great work, team security in serverless cloud. Any ETA for CodeSec SCA, which is software composition analysis?
I think it's planned for this summer. So few weeks and you will be able to use also SCA. At the moment, we have only serverless and scan.
Amazing. So coming very shortly.
Yes.
So keep an eye out for that.
Yeah, and please send us feedback. So we made this for developers, so because we want to help developers secure their serverless environment or any other application with SCA and scan. So, and we need your feedback to make it better.
Sure. Thank you so much for joining us, and please do join us for the chat at this Discord, and we'll look forward to having you in the future sessions as well.
Thank you very much for having us.
It's a pleasure.
Thank you.
Thank you.